Hey everyone, this is Patrick again. Today we're going to make an app that when we run it is going to pull data from the Reflect API and send it to a Slack message and let us know what's not working. The Reflect dashboard is awesome, but it's preferable since we're already checking Slack in the morning for it to tell us if something's wrong. This becomes especially useful when you start to use the monitoring proxy. This is a Q-Sys component that allows you to monitor the health of third-party devices and add it to your Reflect account. So we're going to get started. We're going to go ahead and spin up a new NPM application just like we've done in the past videos. Now we're going to go ahead and grab the API key from our Reflect account and we're going to add it to a .env file. And by the way, by the time that this video is published, all of these API keys will have been cycled and will no longer be valid. We're going to make a source folder with all of our helper JavaScript code and add a few dependencies from NPM. Then we're going to make an object called creds, which is going to hold that API key, a header body, which is how we're going to pass it, and later our Slack webhook key. Export that and move over to index.js and import it again. Also going to import Axios, file stream, and the Slack NPM module. Next, we'll import the base URL for the API calls that we're going to use. I have the main and the beta because I'm using the beta, but most people will be using the main. I'm using the beta, I'm going to make an object that is going to filter out only my Q-Sys cores that are on the Reflect account. If I hit F8, I can see the names for my systems and I will add them to that object. Now I can write my first function that is going to take all the data from a given API call path and return it as one body. The API calls I'm using are here, are the systems call and then the items call at a given system ID, which I need to take from the systems call. At this point, it's tempting to start filtering out the data. For example, I'm going to be looking for systems that don't have a status value of 0. But at first, I want to just take all of the data, and once I have it, figure out what I want to do with it and figure out how I'm going to format it best. I can go ahead and export that function, add it over to app.js, and then run that function with systems as the argument. And then I will see the data coming in. You can see that it's my data because at design.name, you'll see tutorial_main, which is one of the systems that I have added to the Reflect account. Now I'll write a second function called getAllData, which is going to use that first function a couple different times to iterate through the nested data structures and pick out all the data that I need. It starts with that systems call that I just demonstrated, and this is where I'm going to filter out for just my systems. I'm also going to add some logging to the console, so when the application runs, you can kind of see what it's doing as you're watching it run. Here's an example of me running the beginning of that getAllData function, and all it's doing is just picking out my systems filtered out from the Reflect API. I'll go ahead and copy some of that sample data in my index.js so I can see an example of the kind of data I'm going to be looking for when I parse to find those items within each system. I still want to keep that original system info because it has some information I need, so I'm going to be creating two different bodies of data. One is the information for the system, and one is the peripheral data. You can see that my peripherals array is still empty because I haven't written a second API call to pull that data at the given system ID that I got from the first API call. We'll do that now by running that first function again, but with system ID added to the path variable. You can see that my first sysinfo object gives me that ID so I can pass it through to the second API call. As this function iterates, I want to be writing comments to make sure that I as the user know what I'm doing. So as I'm getting items, I'm going to indent it with a sideways arrow to see what's going on. Then as I'm iterating through the peripherals, I'm going to push each peripheral's information into that peripherals array. That's going to run for a little while depending on the size of the file and how many peripherals, and when it's done, I want to put a comment to let you know that it's done retrieving all the data that it's going to. You can notice here that even though I have all the data that I need, JavaScript is not going to print it until I'm calling the data structure more specifically. Now we get to the fun part, which is where we parse through all of this system and peripheral data and we start looking for statuses that are unhappy in some way. And because this information is eventually going to be passed as a single string to a Slack message, we're going to do it by concatenating a long string as we find out more information. I'm going to stop here so that you notice that when you have a word nested in 2 colons, if Slack has that word in its database of emojis, it's going to write it as an emoji and not the word itself. And the other day I created a Q-Sys emoji in my Slack account. Now we're going to write a small helper function that's going to help us concatenate that long string that we eventually send to Slack. Remember that \n is a line break. That's what we're going to do to help us write a clean message that is easy to read. So now that we have built tools to retrieve and format the data, we're going to put it all together. Object.entries is our best tool to be able to do this. Within object.entries, name is going to be the name of each system, and details is going to be all of that nested data that we're parsing through. If I log just the name variable to the console, you'll see the name of my systems. If I log just the details of the console, you'll see all of that nested data, which is what we are primarily interested in. You can see that within details, I can pull data that is as specific as I want it to be according to my needs. If you're originally a Lua developer, you should only be familiar with tables, but JavaScript has arrays and objects, and the functions that we choose to iterate through each of them are different depending on what the data structure is. Now, because this is an application that is monitoring the health of our system, the attribute that we are mostly interested in is status. Within status, we care more when an entire system is offline versus a given peripheral, and we care more than if a peripheral is offline than whether a system status is fully healthy. Later, we will add a few sorting functions that will organize that data into the hierarchy of how much we care. You can see in the scripting that I have a few different options for how to demonstrate whether or not a system is healthy. I'm also adding a few emojis to make the Slack message more fun and easy to read. After that, the fun challenge becomes digging through all of those nested data structures I have available to me and making an easier to read data structure which I can turn into a string. So I'm essentially making all of that data into an easy to read single object of data that is what I care about. And for example, some of those Q-Sys peripherals will report their IP address. So if I'm on the network, I want to be able to click that IP address, so I want it written right there in the message. But the majority of the peripherals don't, so I'm not going to add anything if it's not there. You can see now that I'm adding to the message that miniature data structure that I made, but I'm doing a .replace function to remove the quotes and the brackets so it's easier to read. It's fun to know a few regular expressions for an application like this. Regex and pattern matching in Lua are very similar to each other. You can see now that when I run this function, I'm getting a long string of text that is very soon going to be a Slack message. If a system is having issues, it will go through the peripherals and see which peripherals are having issues, and if not, you'll just get a green check mark saying it's good to go. You can notice that the text on this message aligns with the statuses that we're seeing in the Q-Sys designer. If I were to go ahead and log on to one of these cores and navigate over to utilities and reboot it, you would see that the entire system would report as offline if we were to run the application again. So now we'll get to the fun part, which is initializing our application in Slack. You can see that I've done it already before. We'll go ahead and make a new channel called Q-Sys Daily Reports. We'll then move over to the Slack app marketplace and we'll make a new Slack application. Most modern web applications don't allow you to have a key that lets you do whatever you want. You have to add scopes that align with your needs. For this application, we're going to allow it to write, which is a subset of the chat scope. To get that API key, we're going to go ahead and add it to our .env file like we've been doing with all other secrets. The next piece of data we're going to need is the channel ID that you see on the information for each given Slack channel. So now we'll go back to our JavaScript app with all the new information that we have, and we're going to be able to finish up this application. Slack's API documentation is really excellent, so this script is more or less exactly out of that with just a few mods. One thing that I did forget to do is I needed to add this new Slack app to the given channel that we're going to be posting to. Now when we run the application, all we need to do is hop over to this new channel and we can see that the data is populated. And once again, if I go over to the web page of one of the cores and I reboot it, I can rerun the app and see in Slack now that the core is offline. The last thing I'm going to do to index.js is add these two sorting functions that put the offline systems first, the offline peripheral second, and the online systems third. You can look on the repo for more details. Pay attention to how I'm putting things on and offline in Q-Sys and how it's being represented in Slack. So one of the main points of this application is I want the data to come to me. I don't want to go to it. I don't want to have to run this application. I want it to automatically run and post to Slack every single day. The entire AV industry is way behind on its DevOps game. What we're about to do is pretty simple if you're a DevOps engineer, but I really don't see it happening a lot in AV. We're going to put this script into a pipeline and automate it so it runs every day by itself. This is done pretty easily by adding a YAML file which interacts with GitHub's workflows feature. So once you push it up into version control, GitHub knows to follow this YAML's instructions. And all it really is a bunch of CLI instructions that build up an environment, import some API keys, and then run the application. Aside from not having added the API keys yet to the GitHub repo, I always make some sort of syntax error with these YAML files. So I push up to version control and I see what happens. Even before that, I made a mistake pushing up to GitHub where I forgot to add the local files to the remote repo that I pulled. So now that that's done, I'll go over to the action section and see what kind of errors I created. The first one says that I have a syntax error on line 26, but when I look at line 26, it looks all good to me. Seems like a good occasion to hop over to ChatGPT and see what kind of help it can give me with this YAML file. ChatGPT helped with one issue, but it created another. We'll get to that in a second. Once I run it again, I can realize that in my package.json file, I forgot to tell npm start to run node app, so I need to fix that next. I'll commit that correction to GitHub and I'll try it again. Now, when I look into this, I can see that I got to the part that I was waiting for. I need to add my API keys in the secrets section of GitHub for it to pull. Because remember, I don't want them to be visible on the repo to other users. So even though the YAML file had some syntax for pulling secrets and creating them and adding a sudo.env file, I hadn't added the secrets themselves. Once I run that again, I can see the error that ChatGPT created for me. It added Node version 12 into the build file. Well, a lot of the syntax I'm using didn't exist in Node 12, so it's calling functions that don't exist. So I have to delete that and try again. So once I push that new update up to version control, I can give it one last try. And here you can see for the first time we have an error-free build. So on the YAML file, there's a cron section, which is going to be a schedule. So every day at 8 a.m., it's going to run the same application. And that's going to be the whole point of this. The data comes to us. We don't have to go to it. Thanks for listening. I hope you enjoyed this lesson. Have a good one.